In this episode of Everyone Proofs, we're going to talk about the 4 different types of triangle congruency. The first 4 have to do with non-right triangles. Those are SSS, 3 congruent sides, SAS, 2 sides with an angle in between, AAS, 2 angles with a side off to the side, and ASA, 2 angles with a side in between. The 4 right triangle proofs are HA, which deal with a hypotenuse and an angle, HL, which deal with the hypotenuse and a leg, LA, which deal with the leg and an angle, LL, which deal with 2 legs. The ones that don't exist are AAA, ASS, the curse word, or the backwards version, SSA. Those don't exist.
Proof 1 of proof 5's, 5 proofs. Write a 2-column proof. I'm given BA is congruent to DC. So one side BA is congruent to side DC. So that's this guy, that's this guy. I'm also given that BAC, angle BAC is congruent to angle DCA. That's BAC is this guy, and DCA is this guy. Okay? Okay. So this is what I have so far. And I like what Ms. Harris did the other day, so I'm going to copy what she did. She wrote out the fact that we have a side right here. These 2 sides are the same. Also, you have an angle right here. Now, when you have 2 triangles glued together, which is what I have, 99% of the time you're going to use the Santiago special, and that's going to be this side in the middle. And of course, dummy over here forgot to write out given. Dummy over here. Now, what was I saying? Okay, so I have the San Diego special. I have the San Diego special, which means I have AC is congruent to AC. And we know that to be the reflexive property. I'm ignoring that. Now, I can say that these 2 triangles, ABC, are congruent to each other. So I guess that would be CDA. And since I have a side and an angle, and now a side, the angle is inside the side. Side angle side is going to be SAS. I know it says prove here that 2 sides are the same, but we're not going to do that. We're just going to stop at the fact that the proof, we're proving 2 angles or triangles are the same. So we're going to stop right there. That's proof number 1 of 5 proofs. Okay, so the trick here is you're usually given 2 facts or 1 fact, and you have to find out another fact. And the 2 facts that we were given was a side and an angle. A side and an angle. So I know it's going to be one of the SA ones. It doesn't say anything about these being right triangles. So we can't assume that these are right angles. I know you want to, and I know you want to be like, well, that's kind of like HA, but it's not. We don't know if that's true or not. So we had to find a 3rd thing, and that was the 3rd side. And by finding the 3rd side, we were able to say S with an A in the middle of another S. Yeet. I'm going to zoom up on that part real quick because it's kind of hard to see. don't think I'm going to get it much better. Terrible job by me getting such a bad picture. Terrible job by me. Let me do this at least. Try to straighten things out. And try to clear that up. Okay. So I'm going to write out the given anyway. So don't freak out too much. Okay. This is what the given says. Angle W is congruent to angle Y. All right, so even if you have a hard time seeing the wording, you can still see the letters. That angle W is congruent to angle Y, so I have an angle. Okay. Also, this says that WZ is congruent to YZ. So that's WZ right here is congruent to YZ. Now, I know what you're thinking. You're thinking the Santiago special. I'm sorry, I mispronounced it. The San Diego special. And you can't, though. If you think the San Diego special, then the proof that you're trying to do is the AS other curse word. And there is no curse word proof. Okay, and if you're wondering, well, no, isn't it SAS? No. Because if you were to use the San Diego special, you are doing a side. And since there's no angle in between the side, then you're creating the curse word, which we're not allowed to do. Okay? So we have to rely on the fact that XZ bisects angle WZY. All right? So all of this is my given. Now, in my Instagram and in the class the other day, we looked at this phrase in particular very, very, very closely. Okay, so let me be clear again. If I see the word bisect, I'm looking at two things. If it says the phrase, this bisects an angle, then what we all of a sudden care about is the two angles being congruent to each other. If it says this bisects a side, then all of a sudden I care about the two sides being congruent to each other. You can't see that. So the wording is extremely important because here it says XZ bisects an angle. And since the given is telling me that my line bisects an angle, I now care about two angles being congruent to each other. Since it talks about bisecting an angle, I now care about two angles being congruent to each other. So XZ bisects WZY. So it bisects this angle down here, WZY. So since it bisects the angle, this angle is going to be congruent to this angle. And so what we're going to say is WZX angle WZX is congruent to angle YZX. And that's because of the word bisect here. So we will say definition of bisect. So now what I have in my picture is I have an angle, side, angle. I have two angles with the side literally in between. So my final answer is now I can prove that XWZ is congruent to XYZ because of angle, side in the middle of another angle, ASA. And that's my wife yelling at my children if you can hear it. Okay. Again, the key word is you want to think Santiago special. San Diego special. But you can't hear because it gives you the curse word proof. And just like we don't use curse words in real life, we don't use them in math either. Right, gang? Yes, Mr. Perich. Thank you. This one's different. I believe I was going to do this one the other day, and we ran out of time, and I was like, nah. And I was all like, nah. So let's analyze what we have here. Triangle QRS. So that's this whole triangle. Triangle QRS. I meant hooves. I don't know what that means. Obviously, I said something. Angle, oh yes, angle QRS is isosceles with QR being congruent to SR. Okay, so that's thing number one. Triangle QRS is isosceles with side QR being congruent to side SR. Listen, man, I don't remember what I had for breakfast this morning. Asking me to bring up what I said at Christmas time is a different story. What other information do we have? Ah, yes, the old bisect word. Angle side RT bisects side QS at point T. That's my given. That's my given. All right. So I was told one thing. I have to use the information that I have to find other things. And let's do, which one do I want to do first? Let's do this. Let's do the order that it gave us. If QRS is an isosceles triangle, not only are two sides congruent, two angles are congruent as well. So if these two sides are congruent, then these two angles, the angles opposite of the sides, are going to be congruent too. So we could say angle SQR is congruent to angle QSR. And that's the definition of an isosceles triangle. Oof. I have to remember that orange doesn't show up well at all. Shame on me. Am I allowed to do the San Diego special for this? Am I allowed to do the San Diego special? I can't, because if I do, it gives me an angle, side, and then the side. And since it's not, it's angle, side, side, and the angle's not in between the sides, it's the curse word, so I'm not allowed to do the curse word. So I'm going to use this second fact. If RT bisects QS, then that means QT, the side is obviously named after me, is congruent to TS. Now, remember, in the last problem, it said this, that a line bisects an angle. And so since the line bisected the angle, that led us to say that two angles are congruent. Here, it's saying a line bisects a line. So we could say two lines are congruent to each other. QT is congruent to TS, and that's by definition of bisect. So now what we have is we still have, and if you're wondering, well, wait a minute, we couldn't do the San Diego special because you said it because there would be another side. I did. But in this case, we have a side with an angle in between another side. You're not allowed to do it otherwise because it spells out a curse word. And cursing is one of the many tools that the devil uses to make kids make bad choices. And I'm going to agree with Santiago that we have QRT. QRT is congruent to SRT because of SAS, he said. And here's how you know it's SAS. Side, angle in between, another side. Side, angle in between, another side. Again, it's just like the first problem that we did. It's very tempting to want to do one of the right triangle ones, like, you know, an HL or something like that. And in this case, it would be the HA, but we don't know if this is a right triangle or not. We don't. So since we don't know, and since we're not given absolute proof, we can't just assume that it is. If it doesn't say anything about right triangles, if it doesn't say anything about midpoints, if it doesn't say anything about angle or whatever, you can't do it. Oh, and wouldn't you know it, it's almost as if I led you to this creek to drink out of the delicious waters of a right triangle waterfall. Given AD is congruent to BC. So AD is congruent to BC. So this one and this one. Also, A and C are right angles. Angle A and angle C are right angles. That's my given. We now have information about right triangles. So I am allowed to use either HA, HL, LA, or LL. And of course, this stands for I have a hypotenuse and an angle. I have a hypotenuse and a leg. I have a leg and an angle, and I have a leg and a leg. Well, right now, all I have is a leg. This is a leg. Remember, the legs are the shortest sides, and the diagonal, the longest side, is always going to be the hypotenuse. So I have a leg. So this one's out of the question. At least I don't need this one, because I have a leg. Can I use the St. Diego special here? Could I use the San Diego special? Yes, I can. Yes, I can. I could say that BD, for best dude, is congruent to BD. And that's reflexive. Do I have enough information to use one of these three? You sure do. You sure do. I can now say that ABD is congruent to CDB. And which one of these remaining three can I use to prove that those two triangles are the same? Is it going to be the HL, the LA, or the LL? It would be the HL, because I have two hypotenuses that are the same, and I have two legs that are the same. And since this is a right triangle, I'm automatically given an angle. A hypotenuse is the longest side of a right triangle. So if you were to isolate one of these right triangles, the longest side would be DB or BD. The slant. What do we use? HL. So far in all of these problems, I was allowed to use the Santangelo special, but only in two of the cases would it actually help me. Now, if you remember the picture that I posted on the diagram the other day, and we went over in class and then I posted it on diagram, we focused on three things and we hit on all three things today. The three things that we cared about when I posted on diagram the other day was if you see this phrase, a side bisects a side, and so when that happens, you could say that two sides are equal to each other. We also saw the phrase, a side bisects an angle. And then so we were able to say that two angles are the same. And now today, we're finally seeing this thing, that two sides are parallel to each other. Even before that, we see another word, midpoint. So one of the things I want to stress, and I already stressed it earlier today, is sometimes when you guys would do your proofs, you would say, oh, these two sides are congruent because of the word midpoint. Like, it's very, very, very tempting to do this problem and try to explain something by saying, oh, blah, blah, blah is the midpoint. But since we don't talk about midpoint anywhere in the given, we are not allowed to do that. So you're not allowed to say, well, this is equal because of midpoint if it never says midpoint. Or this is equal because this is a bisect if it never says bisect. Like in any of my explanations here, like I might want to say like, oh, look, V is right in the middle of everything. So V bisects stuff. Well, I'm not allowed to say that. And I'm not allowed to say that because nowhere in here does it say the word bisect. So make sure on the test, if you see the word bisect, you use the word bisect. But if you don't see that word, don't use it. Now, I'm obviously going to use the word midpoint, and I'm obviously going to deal with these parallel lines somehow. Okay, so let's do the midpoint. Let's write it all out first. V is the midpoint of WY. I'll explain what that means in green. Just give me a minute. UY is parallel to XW. All of this be my given. All right. V is the midpoint of YW. What does that mean? V is in the middle of YW, which means YV and VW are congruent. Am I allowed to say that UV and VX are congruent? No. And here's why I'm not allowed to say it, because it never says that V is the midpoint of UX. So even though it probably is, I'm not allowed to say that. I'm not. All right, so first thing number one that we're going to write out is since V is the midpoint of YW, I'm allowed to say that YV is congruent to VW. Volkswagen! And that's the definition of midpoint. The key with parallel lines is whenever you see parallel, that usually leads to alternate interior angles. So what I can say is since UY is parallel to XW, I could just pick these two angles and say these two angles are congruent. So angle UX, or U, is congruent to angle X. Now, why these? Because these are the alternate ones. You know what else I could say? I can say that angle Y is congruent to angle W. And the reason for these guys is the definition of alternate interior angles. Now, a lot of you might be thinking, let's go one step further and say that these two angles are congruent because they're vertical, which is 100% true. But you know what? I don't have to do that. Why? Because right now I can say that triangle UVY is congruent to triangle XVW. Because there is such a thing as angle, angle, side. There is an AAS. And I'm done. And before we call it a day, remember you have 8 proofs. You have 8 different types of proofs. Okay, you have SSS. So if you have 2 triangles, right, and you're able to prove that that side, and that side are all the same, then you have 2 congruent triangles. You have SAS. So if you can prove that, let's do this. If you can prove that that side is congruent to that side and that side is congruent to that side, and you're like vertical angles, then what you have is a side with an angle in between another side. That's SAS. You have AAS, which is what we just did. AAS is if I give you 2 triangles and you're like, here's an angle, here's another angle, and the side not in between them. Angle, angle, side. Angle, angle, side. You have one of those. One of those. You have ASA. So that angle is the same as that angle, and these 2 angles are the same. And in between your congruent angles, you also have a congruent side. Those are your 4 main ones. From there, we also have hypotenuse angle. So if I give you 2 right triangles, tell you that these are definitely right. See, in these, even though some of these might look like the green one right there, that looks like a right triangle, do I ever say it's a right triangle? No, then I can't prove it. If I give you the right triangle information, you're like, here's an angle, these 2 angles are the same, and look, they're the same hypotenuse, then I have an HA. If you have an HL, and I have definitely a right triangle, and definitely a right triangle, and I can show that 2 of the hypotenuses, or both hypotenuses are the same, and that a leg on each are the same, then I have HL. I also have LA. So if I have definitely a right triangle, definitely a right triangle, these 2 legs are the same, and these 2 angles, any 2 angles are the same, then I have LA. And last but not least, I have LL. So if I have, that's definitely a right triangle, That's definitely a right triangle. That leg is the same as that leg, and that leg is the same as that leg. Then I have LL. The ones that don't exist, there's no such thing of. There's no such thing. Oh, you know what? I want to do red again. There's no such thing as AAA. There's no such thing as AAA, and there's no such thing as the curse word. So you can't be like, oh, look, these three angles are the same. They're congruent because of AAA. There's no such thing. Oh, look, you have an angle, and that side and that other side way over there. No, that's the curse word. Can't do that.